Namaste children, I am Hari Prasad, your chemistry teacher. Children, today's topic is hydrogen chloride. What is hydrogen chloride? It's a colorless gas. Odor, pungent odor. Taste, sour to taste. HCl is present in the tummy of mammals. How? Yes, gastric juice contains what? HCl, which is responsible for digestion of food. Children, we all know that HCl is a what type of acid? Monobasic acid. That is, when HCl dissolved in water, it produces one H plus ion, right? This H plus ion is responsible for acidic nature. We all know that H plus is not stable, that in turn combines with water to produce what ion, children? Hydronium ion. How do you define an acid? An acid is a compound which produces hydronium ion as the only positive charged ion when dissolved in what, children? Water. What is the proof that HCl is an acid? Definitely, it will change the color of the indicators. That is, it will turn moist blue litmus red, colorless phenolphthalein to colorless methyl orange to red, and pink color alkaline phenolphthalein to what, children? Colorless. All these things you have already seen in my previous video. That is colors of indicators. Now children, HCl. What is the type of bond present in HCl? Right? We all know that when you compare H and Cl, Cl is more electronegative. Right? Because Cl is more electronegative, the shared pair of electrons are closer towards what, children? Cl. It is something like this. The shared pair of electrons are closer towards Cl. Because of this one, what will happen is that Cl is going to acquire a slight what charge? Negative charge, and H is going to acquire a what? Slight positive charge. Because of the formation, that is because of the difference in the electronegativity values, there is a formation of a positive pole and negative pole. That's why we say the type of bond present in HCl is polar covalent bond, and this compound is called as what, children? Polar covalent compound. Now, because of this reason, HCl is very much soluble in what? Water, which is also a what compound, children? Polar covalent solvent. Now, but you know what, children? Actually, we generally don't collect HCl over water because our HCl is highly soluble in water. That is, 1 volume of water can dissolve 452 volumes of what, children? HCl. Right, children? Now, coming to the laboratory preparation of HCl, one more thing. What is the molecular mass of HCl? Atomic weight of hydrogen is 1. Atomic weight of Cl is 35.5. If we add these two, it is nothing but 36.5. Half of 36.5 is nothing but what, children? 18.25. Children, what is 18.25? 18.25 is nothing but what, sir? Vapor density of what? HCl. Children, how did you calculate this, children? We all know the relationship between molecular mass and vapor density. Molecular mass is equal to 2 into vapor density. So, vapor density is equal to molecular mass by what, children? 2. That is, half of molecular mass will give you what? Vapor density. Right? Vapor density of HCl is 18.25 and vapor density of air is how much, children? 14.4. Now, when we have a HCl and a air in a container, which will be on the top and which will be in the lower end? Common sense says that 14.4 is lighter and 18.25 is heavier. So, air will be on the top and HCl will be in the bottom. That is, when HCl enters, air comes out like this. So, conclusion from this one is, if anybody asks you how HCl is collected, HCl is collected by what, children? Upward displacement of air. This is not a dance step. Right, children? Now, HCl preparation. Now, children, give me an example or some salt which contains Cl in your kitchen. Which one is that? Yes, you're 100% correct. The salt which contains chlorine is NaCl. Without this, you cannot prepare the sambar. Right? Now, children, by making use of this salt, we are going to prepare HCl. Only NaCl cannot be used. Along with this one, we are going to make use of king of chemicals. Who is that? Sulfuric acid. NaCl, when it is heated with sulfuric acid, you will get NaHSO4 plus HCl, right? Observe the second equation also. NaCl, again when it is treated with H2SO4, you will get Na2SO4 and HCl. Children, I don't know whether you observed this or not. Reactants in both the equations are same. Products are also same. That is, you are going to get HCl gas. But only the difference is that byproducts are what? Different. You are getting NaHSO4, which is a salt. What type of salt it is? It is a acid salt, and Na2SO4, which is called as normal salt. Now children, one simple question. What is the difference between HCl and H2SO4? Hey boss, HCl is a one which will produce one H plus dissolved in water. That's why it is a monobasic acid. And H2SO4 is going to produce two H plus ions when dissolved in water. That's why it is called as what, sir? Dibasic acid. Because it is dibasic acid, sulfuric acid is going to produce two types of salt. That is, one is acid salt and another one is normal salt. Now children, what is the name of this reaction? It's very simple. According to me, we are going to get a gas HCl. Who is responsible for this HCl? It is sulfuric acid, right? How it is displacement reaction? See, sulfuric acid is a non-volatile acid. Because HCl is coming out as a gas, I will call it as what, sir? Volatile. That is, non-volatile sulfuric acid. 1 minute. I hope you know what is the difference between volatile and non-volatile. Let me give a simple example. Boss, you take 1 glass of petrol, right? And 1 glass of castor oil. Keep both the glasses in the atmospheric air. After a few hours, you just go and pick up those 2 glasses. What is the observation? The glass which contains petrol, it's missing, right? Evaporates. What will happen to the volume of the castor oil? No change. Conclusion from this one is, petrol is what, children? Volatile. And castor oil is non-volatile. That is, volatile is the one whose boiling point and melting point is what? Very, very low. And non-volatile is the one whose melting point and boiling point is very, very high. Now, sulfuric acid boiling point is very, very high. That's why I'll call it as what, sir? Non-volatile. And whereas HCl is volatile. Now children, sulfuric acid non-volatile displaces HCl, which is volatile, from its salt. What is that one, children? NaCl. Just because HCl can be prepared from NaCl, I will call NaCl as what, sir? Salt of volatile acid. I'll call it as what, children? Salt of volatile acid. So this salt can be used to prepare which volatile acid? It is HCl. Now children, coming to this one. Why the same reactants are giving 2 different products? Just you vary the what, children? Temperature. When the temperature is less than 200, you are going to get a acid salt. And when the temperature is more than 200, you are going to get a normal salt. An acid salt is the one which has got a replaceable hydrogen. A normal salt is the one which does not have any replaceable hydrogen. Now children, who is the friend for SO4? 2 hydrogens. Who is the friend for SO4? 1 hydrogen, and 1 more hydrogen is replaced by sodium. That is, out of 2 hydrogens, only 1 is replaced by sodium. This we call it as what? Partial replacement, which results in the formation of acid salt. And who is the friend for SO4? 2 hydrogens. Who is the friend for SO4? 2 sodiums. Both the hydrogens are replaced by sodium. This we call it as what? Complete replacement, which results in the formation of a normal salt. Okay children? Okay children, this is the apparatus that is required for the preparation of HCl in the laboratory. That is, we want a round bottom flask which is fitted with a thistle funnel, and we have a aspirator bottle which is filled with concentrated sulfuric acid that is acting as a drying agent, and we have a collection jar in which we are going to collect our dry HCl. Now children, initially, how to start? See, we have already taken sodium chloride in this round bottom flask, right? So through this Thistle funnel, we are going to add concentrated sulfuric acid followed by little heating, right? So temperature preferably less than 200. Why it is less than 200, we'll discuss later. Now, once you heat it, you are going to get the bubbles of HCl. I hope you can see this bubbles of HCl gas, right? Which contains some moisture. So that HCl gas is going to, like the HCl is passed through this aspirator bottle, which is filled with concentrated sulfuric acid, which will make sure that all the moisture is removed and the HCl, which is dry, which is free from moisture, is collected in the collection jar. That is, as soon as the HCl enters here, the air comes out. That is, HCl is collected by what, children? Again, it is collected by upward displacement of what? Air. Now, how do you confirm that this glass jar is filled with HCl? What we do is that we take a glass rod dipped in what? Ammonia. When it is brought near the mouth of the collection jar containing HCl, you will get NH4Cl. How do you identify that it is NH4Cl? You will get dense white fumes. This dense white fumes formation indicates that it is nothing but ammonium chloride, which is a product of ammonia and HCl. Children, this dense white fumes I'll show you after this explanation is over. So this is the laboratory preparation of what, children? HCl. Now, the next question, right? What are the important questions for the board exams based on this laboratory preparation of HCl? Question number 1. What are the reactants that is used for the preparation of HCl? Your answer will be NaCl and concentrated H2SO4. Now, boss, why we have to use only sulfuric acid? Why can't we use nitric acid instead of sulfuric acid? No, we can use nitric acid. No, that is also an acid. Boss, no boss, we cannot use nitric acid. Reason is very simple. Boss, nitric acid is also what? Volatile. And HCl is also what? Volatile. How can a volatile acid be used to produce one more volatile acid? That is, because nitric acid is volatile, it will also volatilize along with HCl. So that's why HNO3 is not used for the preparation of HCl. Instead of that, a non-volatile sulfuric acid is used. Now, next question. Out of these two reactions, temperature less than 200, more than 200, the first one is the preferred reaction. The second one is not preferred. Why? There are 3 reasons. One is fuel is wasted. Alright? Second thing is that the apparatus may break. And the third reason is that this Na2SO4 is formed. No, it will form a hard crust and it is going to stick to the glass, which is very, very difficult to remove. So by keeping these 3 reasons in the mind, the preferred temperature for the laboratory preparation of HCl is less than 200. Right, children? Next one. Why this Thistle funnel has to be dipped inside this sulfuric acid? Why we cannot keep the Thistle funnel something like this? Right? When you do this one, whatever the HCl that is produced, that may escape through this Thistle funnel. That's the reason why we'll make sure that the Thistle funnel is dipped inside this sulfuric acid. Now coming to the second one. But you are using sulfuric acid for the preparation of HCl, no? Yes. Again, why you have taken sulfuric acid as drying agent? Why you can't use calcium oxide or P2O5 as drying agent, boss? Right? Why only sulfuric acid is used as drying agent? Reason is very simple. HCl is an acid. Sulfuric acid is an acid. Acid, no reaction in this case, right? So HCl does not react with sulfuric acid. That's why sulfuric acid is used as a, concentrated sulfuric acid is used as a drying agent. Now children, CaO and P2O5, that is, these two reacts with HCl. It forms calcium chloride and phosphorus oxychloride. That's the reason why we don't use CaO and P2O5 as drying agent. Now coming to this one, I've already told this one. How HCl is collected? Upward displacement of air. We already know that. But I will collect this HCl over water bus. Is it possible? Possible, but HCl gas you won't get because HCl is highly soluble in water. No, that's why we don't collect it over what? Water. Again, how do you confirm that it is HCl? How the jar is? How do you confirm the jar is filled? Again, same old reason. Take a glass rod dipped in ammonia. It will produce dense white fumes of what, children? Ammonium chloride. So these are the important questions for the board exam. Now children, what we do is that I'll show you the preparation of what? HCl. Okay children? Okay children, I'll show you the formation of HCl, that is preparation of HCl. So for that I have taken uppu, that is sodium chloride, from our kitchen, right? So this is the sodium chloride what I have taken, which I am going to take in a dry test tube, right? So to this one, according to our laboratory preparation, we have to add what, children? Concentrated sulfuric acid. So this is the concentrated sulfuric acid what we have in this bottle. Just observe very carefully. As soon as I add concentrated sulfuric acid, see what will happen. Observe very carefully. Right? See? You can see the, what children? HCl gas that is coming out. Right? Now children, I'll show you how do you identify that this gas, let me smell this one. It is having a strong pungent smell. How do you confirm that? How do you identify that it is HCl? Observe here, when I bring a glass rod which is dipped in, I have taken ammonium hydroxide. I hope you can make out this dense white fumes. See, I'll remove this. There is no dense white fumes. Observe now. Yes, I'll dip it in ammonium hydroxide. Observe very carefully. Can you see the dense white fumes now? Yes. This dense white fumes is nothing but formation of what, children? Ammonium chloride. Now, what is the nature of HCl? Whether it is acidic or basic? How do you confirm that? For that, I have taken one blue litmus, right? Which is moist. Observe what will happen. It's blue in color, children. Observe very carefully. See? The blue litmus, which is moist, is turned into what color, children? Red color. See? It has turned into red color completely. So this change in color from blue to red indicates that this HCl is acidic in nature, right? Hope you have understood this one, children. Thank you very much. Namaste, everybody.